Are you a hand talker?
Yeah, I talk with my hands a lot.
All right, so then maybe pop that out just a little bit more. Justifying it, wouldn't mind.
And then the earthquake,
exactly,
you know.
I know.
Yes, we like that.
Yeah,
Yeah.
we do.
That
We like
works,
that.
that works a lot.
Definitely go ahead and justify it, Jeff, so we can
We would watch out for Kathleen's shoulder.
Right.
Kathleen, can you shift to your left just a little bit?
this way.
Yes.
Yeah, I'll get you right there. Perfect. Thank you.
It's a game of inches.
I'll warn you, I have been
Is that Monday
having,
Night Football?
at the workshop yesterday, I had to just stop talking for a minute and cough because I just know, maybe allergies or something, but
Yeah.
that might happen.
The dry air.
Yeah, might need to stop and take.
Tell me when, boys.
Back you up. I think we're good.
Whenever you guys are ready.
Okay.
Do you want eye contact right on you?
Yeah,
Okay.
you're talking.
Okay.
Yeah. So could you tell me your name, your title, and your institutional affiliation?
I'm Ken Hudnut. I'm with the U.S. Geological Survey, and I'm a geophysicist.
Well, can you tell us a little bit about your background and what got you interested in science?
Sure. As I was growing up, I had two very influential grandmothers, influential in different ways. One of my grandmothers was actually a PhD biochemist, and so I think I'm a bit unusual in that the reason I'm a research scientist is that my grandmother encouraged me to do that. So she studied the way in which chemicals influence the development of the fetus, and so she tried to help make she tried to help make it easier for women to carry a baby to full term, and so that was her thing. She worked with hormones, especially female hormones, and that was her research area. So when I would go to visit her, I had a friend who lived near her, and so in the summertime I would sometimes go spend time there. And she just always encouraged us to do crazy stuff. And it was kind of, in a way, her way of conveying what's cool about science to us kids, and it just worked for me. We used to do things like melt wax and then pour it over ice in a milk carton to make candles, but then we would kind of keep going with that and start doing crazier and crazier stuff, and sometimes things would explode, and she didn't let that bother her at all. So she was the one, though, that I took that her career path as an example and realized, hey, I could maybe get a PhD and then have a career just trying to understand things better, doing research science.
What made you decide to go into geosciences?
Well, I think that was almost, I would trace it back to my other grandmother's influence. I grew up in an area close to the Adirondack Mountains, and in that area there's a mine called Barton Mines, and geologists know this, that there's a special kind of mineral called garnet that's very hard. It has a hardness of 7. Not as hard as diamond, but it's a lot less expensive material, and so for industrial abrasives they use garnet a lot. And it's almost entirely from this one mine because it's a special place. Normally garnet, when you break it, it breaks like glass. It has a sort of a curvy, wavy fracture surface. But at this particular mine, the garnets were compressed under the Earth's surface a long time ago, and so they have a stress fracture in them. And you can break the garnet smaller and smaller, and it just gets broken into tiny little cubes that make a perfect abrasive. So they use it for polishing lenses, like people's glasses and everything. And they mine the garnet out, and then they have the garnet tailings from the mine, and people use that to put on their driveways. And I used to love to look in the broken little pebbles in the driveway and find garnets and then bring them to my other grandmother. And she used to always thank me, and she loved it that I would bring her a little gift when I would come visit. And so she encouraged me to, she called me Hawkeye, which is from the Last of the Mohicans. Hawkeye was the guy that was the really good shot. So I thought that was pretty cool to be called Hawkeye, and it was because I could find these garnets. And so that was when I was just a really little kid, and that got me starting to look down, looking at rocks. And it also motivated me, I think, to really get interested in climbing in the mountains right there in the Adirondacks. And there are a lot of really interesting things about the geology of the Adirondacks, and that's when I think I started to really get into it. And I was pretty young, and I also, at the time, lived in Rochester, New York, and they had a great planetarium there. And they had programs at the planetarium that explained about all different aspects of the planets, the solar system, but also in the parking lot, they had really cool rocks in between the parking spaces. So again, I just started a rock collection back in those early days. I was probably about 6 or 7 years old then.
Where did you go to college?
I went to Dartmouth College in Hanover, New Hampshire. And when I started there, my freshman fall, I took a class called Rocks for Jocks, otherwise known as Geology 101. And my professor, Dick Burney, was just great. And just one day after another, you'd go into this class and get one mind-blowing concept after another. You know, one day it would be geological time, and you'd start with the molten formation of the Earth, and then, you know, just the evolution of life, and kind of all in one lecture. And you're sitting there going, oh my gosh, this is amazing. So that was just a great class for me. And so I majored in earth sciences there. I really enjoyed the fieldwork aspects of it and international travel. So there were some things about it that I really liked.
Could you describe your field of expertise as if you were talking to a youngin?
Sure. My field of expertise is earthquake research, and in particular, I study the San Andreas Fault. So this is a big, famous fault that probably most people have heard about, and the reason it's well known is that in 1906, of course, there was the San Francisco earthquake, and it was devastating. 1857 in Southern California, there was also a big earthquake on the San Andreas Fault. And so what my colleagues have been doing for many years is they've been cutting into the San Andreas Fault and studying the layers that have been offset in prehistoric earthquakes. So one of the things I'm doing nowadays is I'm leading an effort called SOSAFE, which it stands for the Southern San Andreas Fault Evaluation Project. That's part of the Southern California Earthquake Center. And in that special project, we have a large number of investigators that are out doing trenches across the San Andreas Fault, dating prehistoric earthquakes. And then we also have people that look at the correlation of earthquakes between sites, so we can see how big those prehistoric earthquakes were. And so that's one of the things I've been working on lately. We also have been using new technology that's called LIDAR to map the topography along the San Andreas Fault, so we can study the little landforms that were pushed up along the fault as past earthquakes occurred. And so what we do is we fly along the fault only about 1,500 feet off the ground, pretty low to the ground, and the airplane flies along, and there's a laser scanner on there. If you imagine taking a laser pointer and pointing it down at the ground and then zipping it back and forth very fast like that, and then also having it go on and off very quickly as it's scanning. Each time the laser hits the ground and bounces, we record that, and from that we can get a very detailed map of the ground surface. So we've used that technique to also study the San Andreas. Prior to all of those things, I was using GPS, and my colleagues and I were some of the early ones to recognize the use of GPS to see how strain builds up on the San Andreas Fault system. So for about 10 years, that was my main project. We got funding to do this, and then we went ahead and built a network of GPS stations in Southern California. Excuse me a moment.
So the LiDAR is sort of supplanting the GPS methodology, or is it just sort of complements it?
More complements it, yeah. So I just moved on to other things and started doing the LiDAR, but a whole bunch of other people took the concept of what we had done here with the GPS network and then expanded that out throughout the whole western U.S. I'll put this down, yeah. You want me to pick up on that question and do that again?
Yeah, I was just,
without the water bottle?
Yeah, I was just
okay.
sort of wondering, you know, if LiDAR will eventually, or is this supplanting the GPS technology, or just like something that complements it?
Yeah, we're constantly trying to pick up on the latest new technologies and apply those to our field of earthquake research. And after we built the GPS network here in Southern California, we built 250 stations, and that is used to track the accumulation of strain between the Pacific and North American plates. that whole idea was then broadened, and now throughout the whole western United States there are now over 1,000 GPS stations like that. So people use the ideas that we had developed here in the Southern California Earthquake Center and then took that out throughout the western U.S. That's called the Plate Boundary Observatory. Also with the LIDAR along the San Andreas Fault, my colleague Mike Beavis at Ohio State and I received National Science Foundation funding, and we did that laser scan of the San Andreas, and then similarly other people took that same idea and expanded that out, and now they're scanning faults in the same way but throughout the whole western U.S., and that's what's called the Geo-Earthscope project. So in a couple of examples we've applied new technologies here in Southern California, and then other people throughout the western U.S. in the Earthscope project have, kind of gone in that same direction but throughout a much wider area.
What's the most fun and rewarding aspect of your work?
There are a lot. I would say most recently I've been working on the shakeout a lot, and what's been rewarding there is that I feel for many years I always wanted to try to combine the earth sciences with socially relevant aspects, and so this goes back to when I was in high school. I was part of a group in high school called Fully Relevant Educational Days, FRED, and that was one of my main extracurricular activities. And we would bring in people from different careers to speak to students in school about what they do. And so that was just something that I just always wanted to do, something relevant, something that would benefit society. And so when I got into the earth sciences in college and in graduate school, I was kind of always steering in the direction of wanting to do something that would help people. And so it's easy in a research career to get off into an area that's really pretty esoteric, and sure, you can publish papers on it, but it never really is applied. But what Shakeout has done is it's brought